What we're going to discuss today is we're going to discuss testing of a switch mode power supply and utilization of the inverter and backlights as a load on the switch mode power supply. We're going to use two different versions of our product, one with an on power supply inverter and one you see here with an off the power supply inverter, separated inverter. And the purpose behind this training is so we can allow you to utilize test procedures with units that the jig applies to and that the jig does not apply to, which may employ some of our older units. This test procedure should be one that you can use with any LCD TV, and it should be able to quickly allow you to reduce the amount of time that you spend in troubleshooting and reduce misdiagnosis and multiple parts use, where you do not order a power supply unless you need a switch mode power supply. And through the use of jumpers and our meter and using the television for its own load, we should be able to accomplish that to where you can comfortably do this quickly, effectively in the customer's home or in your shop. So now we'll proceed into the troubleshooting methods, and we'll utilize one TV at a time to show you differences in how features can affect your outcome of your tests and how to defeat some of those features so you can conduct the test accurately. Some of the things that we need to understand about switch mode power supply is over the years, utilization of standby power has changed, and the presence of AC detect as a separate conductor. Briefly, we're going to discuss both of these. First, we'll start off with AC detect that's many times developed on the switch mode power supply and sent to the main as a separate conductor. AC detect is utilized by the main board to create reset for the microprocessor. Many times AC detect may be 0 volts at standby and come up to 3.5 volts or 5 volts when the unit is powered on. Other designs may switch AC detect to a high momentarily only when AC detect is reapplied to the television. So there's multiple ways that AC detect can be utilized. When you do not have AC detect that's developed on the main board, the reset function from an AC detect circuit is carried out on the main. It's tapped off of the standby voltage. Now we've got other things that are loading down the standby voltage on some of the newer televisions with higher features also that need to be recognized. Many of the units have a built-in Skype camera. Standby voltage goes to the Skype camera for the only purpose of when the unit is turned on, standby voltage's state, based on the position switch for the Skype camera, lets the microprocessor know whether it needs to load software for the Skype camera's function. You also have standby that's leaving the main board and going to your Bluetooth module and your Wi-Fi module. So you've got additional loads other than just the standard main board on your standby voltage. Realizing that if you're missing standby, unload some of these connections that come off of the main board that standby voltage is applied to, such as your connection here that goes up to the camera. You've got a connection here that goes to your keyboard, IR, Bluetooth, and Wi-Fi modules. Some of them also have a separate conductor that go to some of these Bluetooth and Wi-Fi modules, depending on how the unit is designed and connections on the main board are routed. Now, one of the first things that we want to do is we want to know whether we do have standby voltage. A simple check for standby voltage will require you reading the notations on the screen print on the switch mode power supply. If we've got training material on the particular model you're using or working on, we'll tell you which pins standby voltage is applied. There's a various number of pins that standby voltage is applied to. In some of the newer models, the number of pins has begun to reduce down to 2 conductors, maybe even 3 conductors. Older models, you had as many as 5 or 6 conductors for standby voltage as a redundancy. Some of the newer ones, you only have 2, such as the model that we're working on, which is an LA series product. So the first thing we want to do is we want to test and see if standby voltage is present. it's going to be a minimum of 3.5 volts. If it's running lower than 3.5 volts, around 3.4, 3.3 volts, you may have something loading down that standby voltage. If the standby voltage is not there, you're going to want to unload everything from the main board and just supply only standby voltage to the main only, then retest and see if you have standby voltage. If you still don't, then you may want to open the connection between the power supply and the main board and see if the power supply starts generating the 3.5 volts. If it does at that point, you may have something on the main board that's actually loading down your standby voltage. Okay. Once you've established that we have standby voltage, like I said, we're going to use some alternate methods other than utilizing the jig. Because the jig does work on a lot of the power supplies, there are also switch mode power supplies the jig does not work on. So you'll have to return to some older methods of doing some troubleshooting and forcing the power supply in an on state in order to troubleshoot the switch mode power supply and find out if there's a problem with the power supply. First thing we want to do is to try to force the switch mode power supply into an on state. In some of the new power supplies, you're going to see some different labeling. Many times they'll call the power on line PWR-on. There's a lot of different ways that can be labeled. Leave that to analytical thinking as to understanding what screen print you're reading. Now you're going to have different notations for other on and off control lines such as your backlights or your inverters. And we'll talk about that type of labeling here in just a few minutes. So the first thing we want to take a note of is what pin our power on line is on. Okay. Our power on line is on pin 1. On this connector, the labeling on this power supply and the layout of the pins corresponds. Your blue conductor or different colored conductor is pin 1. Everything in line with pin 1 is your odd pins, and on the other side of the connector is your even numbered pins. So if you're looking at one of our diagrams and we tell you which pin number it is, you should be able to decipher that very easily. Now, one of the things that we want to do is we want to open the connector between the main board and the switch mode power supply to where we can insert jumpers. For this jumper, we're going to use a needle soldered to a piece of wire, and on the other end of that piece of wire, another needle is soldered there. The reason we're using a push pin needle is because it's rigid and we can use it multiple times without it bending and causing a problem with the wiring harness. The tabs on the connector, you need to push those in and pull the connector out. Okay. Once we've opened that connector, now we can use these openings to insert our needles. One thing I want you to take note of is pin 1 is on the bottom, and when it gets to the main board, pin 1 is at the top. None of the connectors are rotated. The entire ribbon cable is rotated. In many of our boards, you'll find that. Now, what we noted a minute ago is pin 3 and 5 are standby voltage. So the first thing we want to do is we want to take one of our jumpers and we want to insert that in pin 3 or pin 5. Now, if we were missing standby earlier, what we want to do is we want to verify that standby is now present. So you can either check it at the pin or you can check it at the end of the connector you just installed. Once we verified that we do have standby voltage, we'll locate the pin for our power on control line. And we're going to bridge standby voltage to the power on control line to tell the power supply that it's turned on. This power supply is switched on by the main board actually applying standby voltage to the power on control line. Bridge power on to standby supply voltage. When we reapply AC power to the switch mode power supply, by the way, never on any television, plasma or an LCD, do you disconnect or reconnect any connector with the unit live. Now, once we make that bridge from standby voltage to power on voltage or power on control line, what you want to do is you want to check and make sure that standby voltage is still present. The purpose behind this is because if the unit is not powering on, one thing that can cause the problem is the power on control line on the power supply have a defect and it be shorted to ground, which then it would take out your standby voltage or cause it to go into overcurrent protect. Then you'll have no voltage coming out of the power supply. If you do not check that, then you're going to possibly misdiagnose the unit. It should lead back to a power supply failure, but we want to make sure that if that voltage disappears, remove the jumper, see if it comes back to life. One quick indicator that we do have power is you're going to have some activity with this LED. Not all of our power supplies have this LED failure indicator on there. If everything is normal when it's connected to the main board and things are functioning properly, this LED should never come on. We have the unit forced into a run condition. The LED will blink periodically in a pattern letting us know there's an absence of PDIM. It can also blink because when the inverter on is turned on, LED feedback or the inverter feedback determining whether the LEDs are creating the correct load on the inverter. So the number of blinks can tell you a lot as to what to look for as far as the failure goes. If the LED's inverter on is not present, then you should get 5 blinks every 3 to 5 seconds. With each model, this can vary somewhat, but it is an indicator where you may want to look for your problem. At this point, when we have this jumper in place, we should be getting all of our secondary voltages out of the power supply. Now, if the inverter is a separate board from the switch mode power supply, you should have 24 volts going to that inverter. But all of our voltages coming out of the power supply that go to the main should be present. On the screen print here, we have listed 24 volts and we have a 12 volt supply. Verify that those voltages are present with your digital voltmeter. Our 12 volts is present and our 24 volts is running about 24.5 volts. So once we know that our voltages are present, now we know that our switch mode power supply is at least producing the voltage. To properly test a switch mode power supply, you do need to create a load for that power supply. You can load the 12 volts by having a 12 volt incandescent bulb and loading the 12 volt line. But usually a proper load for a power supply, we can accomplish that by loading the highest voltage coming out of the power supply. What we're going to use is we're going to try to use the inverter and the backlights as a load for the 24 volts. Now we know that our power supply is coming up and generating all the output voltages that it should be. Now we're going to use a secondary jumper and we're going to jumper another standby voltage connector and we're going to jumper that to the inverter control line. Inverter on, drive on. There's a lot of different ways that they can label this. Some units they'll even label it as BL on for backlight on. In this case, according to the screen print, it's on pin 2. So we're going to put the second jumper on pin 2. Now we can expect multiple things to occur out of this. And we'll use another unit to demonstrate how local dimming can create a scenario that may make you mislead or go the wrong way with your troubleshooting. With only one connector that goes to the inverter or power supply to the main, we know that this one connector has to carry all of our information, such as our global dimming, which is PDIM, our local dimming control lines, which some of the newer units will have multiple lines. You'll have sync going up there. You'll have clock information, and you'll have data also going up there. Many times they're labeling some of the data control lines as SIN, which is different terminology for a type of data line. So we know that all of those conductors are open, so there is no dimming information going to the inverter. So what we expect in those conditions is for our backlights to default to full run condition. Now, through the holes in the back, we can see that our backlights came on 100%. Now we know that our power supply is loaded. Either the 24 volt line or the 380 volt line will feed the inverter when it's built on the part of the power supply. If it's a separate inverter from the power supply, then it's the 24 volt line that's coming out of the power supply that's now loaded. Now, if you do not get backlights at this point, the first place for you to start troubleshooting is to check and see if your standby voltage is running 3.5 volts or running at the correct level. The reason for this test is just like the power on control line, the inverter on line can be shorted on the inverter. And then it will take out your standby voltage and none of your other voltages will come up. If you don't have any backlights, you want to make sure that you do have inverter on going through the wiring harness, getting to the power supply by checking that voltage and making sure that it's present. Because if you have a defect in the wiring harness, then that voltage may not be going all the way back to the wiring harness or getting to the power supply. Now, once we have our power supply loaded, we want to recheck our voltages coming out of the power supply again. And what we want to look for is we want to look and make sure that our 24 volts is at least running a full 24 volts. And that our 12 volts is running at 12 volts.